Hi, today we are going to discuss about selection sort technique. Selection sort is a comparison based sorting algorithm. We can sort elements either in ascending order or in descending order using selection sort method. For example, we can rearrange elements of a list in ascending order by repeatedly selecting the largest element from the unsorted portion and swapping it with the last element of the unsorted list. To sort the elements of a list in ascending order, we do the following. Step 1. Find the position of largest element in the list. Step 2. Swap the largest element with last element of the list. So, the largest element is placed in its proper position. Step 3. Repeat this procedure, that is step 1 and step 2, by excluding last element until all the elements are sorted. Let me explain this with an example. Let us consider the array A, which is having 5 elements. They are 25, 57, 48, 12, 37. The positions are 0, 1, 2, 3, 4. The first step is find the position of largest element. So using a function, we find largest element and its position. So 57 is the largest element. Its position is 1. The second step is swap largest element with last element. So 57 is the largest element and it is swapped with last element. So 57 is swapped with last element of the list, that is position 1 and position 4 are swapped. Position 1 is position of largest element and position 4 is the position of last element. These two are getting swapped so that this becomes 37 and this becomes 57. 57 is the largest element and it is moved in its proper position. So this procedure is said to be a pass. So it is pass 1, first pass. In the first pass, we have identified the largest element and the largest element is moved to its final position. Now excluding 57 because 57 is already sorted. So in the remaining 4 elements, that is unsorted locations, unsorted array, you can say. Repeat the same procedure on the unsorted array. Now again we find the largest element in these 4 elements and we swap the largest element with last element of this unsorted array. That is said to be pass 2. Like this, we'll have n minus 1 passes. When there are 5 elements, we'll have 4 passes. When there are n elements, we'll have n minus 1 passes. I will explain all these passes one by one. Let me explain the passes of selection sort technique one by one. In this example, the array contains 5 elements. The elements can be sorted in 4 passes. In every pass, we perform two things: find large and swap. Find large and swap. There are 4 passes: pass 1, pass 2, pass 3, pass 4. In every pass, we perform two things: find largest element and swap largest element with last element. In the first pass, there are 5 elements from 0 to 4. From 0 to 4, we find largest element and we swap with last element. The same is specified here. Find large in the array A, where the space of array is from 0 to 4. From 0 to 4, find large and swap with last element. Position is 1. So 1 is the position of largest element and 1 is swapped with fourth element. First element is swapped with fourth element. So once you swap this, you will get like this: 37 and 57. 57 is the largest element and it is in its proper position, and the remaining elements are 25, 37, 48, 12. They are unsorted elements, and we repeat this procedure in pass 2. Again in pass 2, in these 4 elements, again we find largest element and we swap with largest element with last element. So here 48 is the largest element. This find large returns you the position of largest element, which is 2. Then swap A position 3. A 2 3. 2 3 means position 2 and position 3 are swapped. Position 2 is 48. Position 3 is 12. 48 is swapped with 12. So 12 here, 48 here. So 48 is the largest element out of these 4 elements and it is placed in its proper position. Excluding this, we repeat the same procedure. So finding large and swapping with last element is said to be a pass. Here we perform this in 5 elements. Here we perform this in 4 elements. Then we perform the same procedure in 3 elements also. 25, 37, 12. Again we find large. See here, find large. Find position. Position is 1. Then swap 1 and 2. Positions 1 and 2. Swap A comma position comma 2. That is in the array A, position 1 and position 2 are swapped. So 37 and 12 are swapped. 37 and 12 are swapped. So 37 is the largest element. It is moved to its final position. Excluding that, we repeat the same procedure on the remaining 2 elements. So 37, 48, 57 are already there in its proper position. Now this is unsorted portion, and in this unsorted portion, that is 0 to 1. So this again we find largest element. 25 is largest element. It returns you the position. Position is 0. And now swap 0 and 1. Position 0 and position 1 are swapped. So 25, 12 are swapped. 25 here, 12 here. So 25 is fixed in its proper position. Excluding 25, we repeat the procedure. But there is only one element. If there is only one element, it is already sorted. So finally, we have a sorted array. 12, 25, 37, 48, 57. So it took 4 passes. Pass 1, pass 2, pass 3, pass 4. In every pass, what we performed, we find largest element, we swap with last element. See here, in second pass, find large, swap. In third pass, find large, swap. In fourth pass, find large, swap. So these two statements are getting repeated 4 times. That is, in an array consisting of 5 elements, we repeat these two statements 4 times. If there are n number of elements, we repeat these two statements n minus 1 times. Every time, which is said to be a pass, in every pass, we find largest element and the largest element is swapped with last element, so that the array consisting of n number of elements will get sorted in n minus 1 passes. Moreover, in pass 1 where there are 5 elements and to find largest element we need 4 comparisons. In second pass we are finding largest element in 4 elements. So it took 3 comparisons by comparing 3 times. In pass 3 there are 3 elements. To find largest element it will have 2 comparisons. And in fourth pass there are 2 elements and to find largest element it will take only one comparison. The total number of comparisons are 1 plus 2 plus 3 plus 4. These are the total number of comparisons. Suppose if the array consisting of n number of elements, it take n minus 1 passes. In the first pass, n minus 1 comparisons. In second pass, n minus 2 comparisons. In third pass, n minus 3 comparisons, etc. etc. In the last pass, it may contain only one comparison. See here, 4 to 1. In the same fashion, n minus 2, n minus 1 to 1. So the total number of comparisons will be 1 plus 2 plus 3 plus 4 plus etc. up to n minus 1. By induction, we can say it is n into n minus 1 by 2, which is n square minus n by 2. The time complexity is directly proportional to the number of comparisons that are made in the procedure. So the time complexity will be considered as order of n square. See here, there is a selection sort procedure. Every time we find large and we swap. Find large and it returns you the position of largest element. Selection sort A, N. A is array, N is number of elements in the array. In general, we write N number of elements are there in the array. Then We repeat these two statements using a first statement. How many number of times means n minus 1 number of times we repeat. So n minus 1 number of times we repeat procedure. So there are n minus 1 passes, but in every pass we find largest element. In every pass we find largest element in the array A from position 0 to a maximum value. Here initially it is n minus 1. Initially it is n minus 1, then it will be reduced by 1. Next time it becomes n minus 2. Next time it becomes n minus 3, etc. So we are performing n minus 1 number of passes. In every pass we are finding largest element. Then we are swapping the element largest position with the last element. Current is last element. So here this is the find large function. This find large function returns you position of largest element. Then swap. It swaps two elements, that is position of largest element and last position of the array. Then analysis of the selection sort. The efficiency of selection sort is calculated in terms of comparisons. The time complexity of selection sort is directly proportional to the number of comparisons. As we have already seen, there are n minus 1 passes, and in every pass we may have some number of comparisons. In the first pass there are n minus 1 comparisons, in second pass n minus 2 comparisons, etc. In n minus 1th pass there may be only one comparison. So all the comparisons are, total number of comparisons are 1 plus 2 plus 3 plus n minus 1, or n minus 1 plus n minus 2 plus n minus 3, etc. up to 1, which will be n into n minus 1 by 2. So the time complexity is order of n square.